Welcome to PostgreSQL exercises, the website that we will use to exercise our SQL skills. Now, I am not the author of this website. I'm not the author of these exercises. The author is Alistair Owens, and he has generously created this website for anyone to use, and it's free. You don't even need to sign up. You can go here right away and start working on it. I believe it is a truly awesome website. In fact, the best at what it does. And I'm truly grateful to Alistair for making this available to all. The way the website works is pretty simple. You have a few categories of exercises here, and you can select a session. And once you select a session, you have a list of exercises. You can click on an exercise, and then here in the exercise view, you have a question that you need to solve, and you see a representation of your three tables. We're going to go into this shortly, and then you see your expected results. And here in this text box over here, you can write your answer and then hit run to see if it's the correct one. The results will appear in this lower quadrant over here, and if you get stuck, you can ask for a hint. Here there are also a few keyboard shortcuts that you can use. And then after you submit your answer, or if you are completely stuck, you can go here and see the answers and discussion. And that's basically all there is to it. Now let's have a brief look at the data and see what that's about. And the data is the same for all exercises. And what we have here is the data about a newly opened country club. And we have three tables here. Members represents the members of the country club. So we have their surname and first name, their address, their telephone, and the date at which they joined, and so on. And then we have the bookings. So whenever a member makes a booking into a facility, that event is stored into this table. And then finally, we have a table of facilities where we have information about each facility. And in there we have some tennis courts, some badminton courts, massage rooms, and so on. Now, as you may know, this is a standard way of representing how data is stored in a SQL system. So you have the tables, and for each table you see the columns, and for each column you see the name and then the data type, right? So the data type is the type of data that is allowed into this column. And as you know, each column has a single data type, and you are not allowed to mix multiple data types within each column. So we have a few different data types here, and they have the Postgres name. So in Postgres, an integer is a whole number like 1, 2, 3, and a numeric is actually a floating point number such as 2.5 or 3.2. Character varying is the same as string. It represents a piece of text, and if you wonder about this number in round brackets 200, it represents the maximum limit of characters that you can put into this piece of text. So you cannot have a surname that's bigger than 200 characters. And then you have a timestamp, which represents a specific point in time. And this is actually all the data types that we have here. And finally, you can see that the tables are connected. So in the bookings table, every entry, every row of this table represents an event where a certain facility ID was booked by a certain member ID at a certain time for a certain number of slots. And the facility ID is the same as the facility ID field in facilities, and the mem ID field is the same as the mem ID or member ID field in members. Therefore, the bookings table is connecting to both of these tables, and these logical connections will allow us to use joins in order to build queries that work on all of these three tables together, and we shall see in detail how that works. Finally, we have an interesting arrow over here, which represents a self relation, meaning that the members table has a relation to itself. And if you look here, this is actually very similar to the example that I have shown in my mental models course. For each member, we can have a recommended by field, which is the ID of another member, the member who recommended them into the club. And this basically means that you can join the members table to itself in order to get at the same time information about a specific member and about the member who recommended them. And we shall see that in the exercises. And clearly, the exercises run on PostgreSQL, and Postgres is one of the most popular open source SQL systems out there. PostgreSQL is a specific dialect of SQL, which has some minor differences from other dialects, such as MySQL or Google SQL that is used by BigQuery, but it is mostly the same as all the others. If you've learned SQL with another dialect, you're gonna be just fine. PostgreSQL does have a couple of quirks that you should be aware about, but I will address them specifically as we solve these exercises. Now, if you want to rock these exercises, I recommend keeping in mind the logical order of SQL operations. And this is a chart that I have introduced and explained extensively in my mental models course, where we actually start with this chart being mostly empty, and then we add one element at a time, making sure that we understand it in detail. So I won't go in depth on this chart now, but in short, this chart represents the logical order of SQL operations. These are all the components that we can assemble to build our SQL queries. They're like our Lego building blocks for SQL, and these components, when they're assembled, they run in a specific order, right? So the chart represents this order. It goes from top to bottom. So first you have from, then you have where, and then you have all the others. And there are two very important rules: that each operation can only use data produced above it, and an operation doesn't know anything about data produced below it. So if you can keep this in mind and keep this chart as a reference, it will greatly help you with the exercises. And as I solve the exercises, you will see that I put a lot of emphasis on coming back to this order and actually thinking in this order in order to write effective queries.